Okay, rational roots word problems, section 3.6. An x-inch square is cut out from each corner of a 9-inch by 11-inch cardboard. The sides of the cardboard are then folded along the dotted lines as shown in the picture above to form a box. How big should x be if the volume of the box is 70 cubic inches? Okay, so volume is length times width times height. In this case, it's length times width times height has to equal 70. So, so the length, the original length of the cardboard is 11 inches, but we're cutting off an inch from each corner. So the length of the box is going to be 11 minus 2x. So length is 11 minus 2x. And the width, the original width of the cardboard was 9 inches, but again we cut off x inches from each corner, so the remaining width is going to be 9 minus 2x. So the width of the box, 9 minus 2x inches. And the height of the box is just going to be x, because that's the part or the amount we're folding up. So that's going to be x. And this product has to equal 70. So this is going to be a polynomial equation. We want to solve this for x. So let's distribute with the FOIL method here. Let's start with the last times last, because we usually start with the x's. Negative 2x, negative times negative is positive. 2x times 2x is 4x to the second. And then the outer product is negative 2x times 11 is negative 22x. The inner product, negative 2x times 9 is negative 18x. And then first times first, 11 times 9 is 99. Okay, so we can combine these two terms. We'll have 4x squared minus 40x plus 99, that whole quantity times x equals 70. And then we can distribute the x, x times each term inside the parentheses here. That'll give us 4x to the third minus 40x squared plus 99x equals 70. And then if we subtract 70 from both sides of the equal sign, we'll get 4x to the third minus 40x squared plus 99x minus 70 equals 0. Okay, so so that's our equation, and we want to solve that for x. Before we do that, let's just note we have some restrictions on x. For example, length and width and height all have to be positive, so we don't want just any solution to this equation. Length is 11 minus 2x, that has to be positive, has to be greater than 0. Width, 9 minus 2x, has to be greater than 0, and the height also has to be greater than 0. So if we solve these, let's add 2x to both sides here, or 2x to all sides. We get 11 is greater than 2x, 9 is greater than 2x, and x is greater than 0. And then if we divide everything by 2, we get 11 divided by 2 is 5.5 is greater than x. 9 divided by 2 is 4.5 greater than x. X is greater than 0. So that means that x has to be between 0 and 4.5. So we can write this as 0 less than x less than 4.5. So x less than 4.5 is the same as 4.5 is greater than x. That's an equivalent statement. So that tells us that x is between 0 and 4.5. Okay, so so now let's apply the rational roots theorem. So our polynomial, the last term is 70. So we'll look at we want the positive divisors of 70 because we're only looking at values of x between 0 and 4.5. So the positive divisors of 70 will be, well, 1 goes into 70, 2, 3 doesn't go in, 4 doesn't go in, 5 goes in, 7 goes in, 6 doesn't go in, 7 goes in, 8, 9 don't go in. We 10, 14, 35, 70. Okay, and then we want the also the positive divisor of our leading coefficient. The coefficient of the highest power of x was 4, so we want the divisors of 4. The positive divisor of 4, 1, 2, and 4. And then x has to be p divided by q. So p is 1, 2, 5, 7, etc. q is 1, 2, and 4. So if we divide by 1, 1 divided by 1 is 1, 2 divided by 1 is 2, 5 divided by 1 is 5, which is already too big. We want x has to be less than 4.5, so we don't need 5 divided by 1. So let's go on to denominator 2. We have 1 divided by 2. 2 divided by 2 is 1, which we already have on our list. 5 divided by 2. 7 divided by 2. 10 divided by 2 is already too big. It's 10 divided by 2 is 5, which is too big. So let's go on to denominator 4. 1 divided by 4. 2 divided by 4 reduces to 1/2, which we already have. 5/4, 7/4. 10 divided by 4 reduces to 5/2, which we already have. 14/4 reduces to 7/2, which we already have. 35/4 is too big. 35 divided by 4 is almost 9, and x has to be between 0 and 4.5. So these are our possible rational roots, and then we can use synthetic division to see which one of these, if any, will give us remainder 0. So we want to write the coefficients. So our equation is 4x cubed minus 40x squared plus 99x minus 70. So let's write the coefficients. 4 minus 40, 99, negative 70. And let's start out with divisor 1 and see what we get here. Bring down the 4 and multiply, add, multiply, add. 4 times 1 is 4. Negative 40 plus 4 is negative 36. Negative 36 times 1 is negative 36. 99 minus 36 is 63. 63 times 1 is 63. Negative 70 plus 63 is negative 7, so that doesn't work. Yeah, this is okay. Okay, so then let's try 2 and see what we get here. So this one's a no. We're looking for remainder 0. Bring down 4. 4 times 2 is 8. Negative 40 plus 8 is negative 32. Negative 32 times 2 is negative 64. 99 minus 64 is 35. 35 times 2 is 70. Negative 70 plus 70 is 0. So this is this has remainder 0. So x equal 2 will be one of our solutions. If we put the x's back into our quotient, we'll have 4x squared minus 32x plus 35, and that has to equal 0. So we may get some additional solutions from this equation here. But this is a quadratic equation. We can solve that with a quadratic formula, and even if there's no rational zeros, we'll get we can also find the irrational zeros. Okay, so we want to solve this equation for the quadratic formula. So A is the number in front of x squared. So A is going to be A is 4, and am I frozen here? Okay, A is 4, B is the number of x, which is negative 32, and C is the number by itself, which is 35. So so we want to the quadratic formula, x equals minus b plus or minus square root b squared minus 4ac all over 2a. So if we plug in the numbers, we get minus negative 32 plus or minus square root negative 32 squared minus 4 times 4 times 35 all over 2 times 4. So double negative is positive, so this will be 32 plus or minus. Negative squared is positive, so it's negative 32 times negative 32 is 1024, and 4 times 4 times 35 is 560 all over 2 times 4 is 8. And then if we subtract 1024 minus 560, 12, 6, 464 over 8. Okay, so 464 is not a perfect square, but there is a perfect square that divides into that evenly. 16 and 464. 2 times 16 is 32. Remainder 14, bring on the 4. And 9 times 16 is 144. So we can write this as 32 plus or minus square root of 16, square root of 29, because 464 is 16 times 29. Square root of 16 is 4. We'll have 4 square root of 29 over 8. And then we can split up the denominator, distribute the denominator. 32 over 8 plus or minus 4 root 29 over 8. 32 divided by 8 is 4, and 4 eighths reduces to 1/2. So we'll have 4 plus or minus 1/2 times the square root of 29. Okay. So now we want to check to see if these fit our criteria. 4 plus 1/2 times the square root of 29 is 6.6 something. That's more than 4.5. Remember, the x has to be between, in order for the length and width and height of our box to make sense, x has to be between 0 and 4.5. So 4 plus 1/2 square root of 29 is too big. 4 minus 1/2 square root of 29 comes out to be 1.3 something, which is less than, it's positive, and it's also less than 4.5. So that gives us two solutions then. So the only solutions that are between 0 and 4.5 inches are x equal 2 inches and x equal 4 minus half square root of 29 inches. And that concludes this presentation.